This video is on domain and range. We're going to do some examples of discrete and continuous domain and range. So for discrete data, this is when data points aren't connected. So the only data points we're going to get are the coordinates that we are given. So we want to determine the domain and range for this set of data. Now remember, the domain are the x values and the range are the y values. We want to list out the x and the y values in order from least to greatest, but we want to make sure we don't repeat any numbers. So when we look at this, sometimes it's easier to write out the numbers that you have and then put them in numerical order so that you don't repeat any of them. So I'm going to get a little sheet of paper and I'm going to write out my x values. So my first x value is a 1, then another 1, a -2, and then a 5. The reason I do this is so that I can see if any of them are repeating, so I can say that I don't need to write out one of those ones. Now I have a 1, -2, and a 5. I need to put these in numerical order, so I'm going to put my -2 first, then my 1, then my 5. So under the domain, I'm going to open up a squiggle bracket, to open up a set, and I'm going to write my numbers in numerical order. So -2, comma, 1, comma, 5. And then I'll close my set because this is all of my domain. I'll do the same thing for my range. I'll find all the y values. So I have a 3, a 7, a 4, and then another 7. So because I have two 7s, I can get rid of one of them because I don't need to repeat any of the numbers. Now I just need to put them in numerical order. So 3 comes first, then 4, then 7. So 3, 4, 7. So I'll do a squiggle bracket, write my numbers 3, comma, 4, comma, 7, and then I'll close my bracket. This is all of my domain and all of my range. This is a discrete data set because these are the only numbers that are included. What that means is that I cannot include 0 or 4 or 8 in my domain because it's not listed. You might have a discrete data set when we're looking at a word problem in real context. So it says the relation g equals 100 minus 20m represents the grade g, so grade, a student makes on a 5-question test depending on the number of questions missed, m. So m is how many questions you could miss. G is your grade. So if we think about this, if you miss no questions, so if you miss 0 questions, you'll make a 100. But if you miss 1 question, that's 20 points taken away from your grade. Then if you miss 2 questions, that's 40 points taken away. So let's think about that. The domain is going to be the x values, it's your input. We input how many questions are missed. So the domain is m, which are the questions missed. So let's think about the number of questions that can be missed. You can miss 0 questions, and that's the least amount of questions you can miss is 0. You can miss 1 question, 2, 3, 4, 5. Now we cannot miss 6 because there's only 5 questions on here. This is a discrete data because I cannot miss half of a question. I cannot miss 8 questions. I only have 0, 1, 2, 3, 4, and 5. So the range would be our output, our grade. Our range is G, which is the grade that the student can earn. So if we think about this again, I'm going to bring out my little sheet of paper. I know that my highest grade can be a 100. But then if I miss 1 question, I'll take 20 points off. So that's 0, 1. If I miss 2 questions, I'll take 40 points off. So then I'll have a 60. If I miss another question, I'll take another 20 points off. If I miss another question, I'll take another 20 points off. And if I miss all 5 questions, I'll make it 0%. So when we write this was our domain, this is our range. This is the information we can input into the problem, and this is the grade that we can get out of it. So when we write our range, again, we want to put it in numerical order from least to greatest. So the range, the lowest grade that a student can make is 0. Then they can make a 20, a 40, 60, 80, and 100. Again, this is discrete because a student cannot make a 50 on this test. They cannot make a 95 on this test. They can only make the grades of 0, 20, 40, 60, 80, and 100. Discrete are not connected. If I were to plot these, I would not draw a line to connect them because the line, if I were to draw these, 0 questions missed would be a 100. Then 1 question would be an 80, 60, 40, 20, and then a 0. If I were to connect them, that would mean that that student could make a 95. They could make a 50, but we know that that is impossible. So we want to keep them discrete by not connecting the data points, because those are the only grades that can actually be achieved. Now we will look at these two as well, continuous data. So the data points are in fact connected, so we do want to connect them. Data points that are connected means that any value in between the start and the end is included in the domain and the range. So if I'm looking at this graph, I need to find my domain, which is the x values, so from left to right. So if we remember from a graph, how far from the left to the right the graph goes. So the furthest number on the left is at 2. So I know my domain will start at 2, and I'm going to include all of my x values. So x's will be in the middle because I have a starting point and a stopping point. So that x value that it stops at is at 8. Now, it's all of the x values that are bigger than 2. That includes 2.1 and 2.5 and 3.5 and 4. So everything from 2, which also will include 2 because it is a solid dot there, all the way until I get to 8. But it's everything that's smaller than 8 but also includes 8. So it's going to be less than or equal to 8. For the range, I'm going to do the same thing, but for the y's. Now, if remember from a graph, it's how far from the bottom to the top the graph goes. So our range, again, if I'm looking at from the bottom to the top, so if I get a sheet of paper, I'm going to cover up the bottom, I'm going to cover it up, and I'll move it all the way up until I can see a graph. So as I keep moving it, I still don't have a graph yet, and now I do. I actually have something here. So that y value is at a positive 3. So I'm going to put a positive 3. I know my y's are going to be somewhere in the middle. Now if I keep moving my paper up, I can still see a graph. So as I move this, the graph is still there. It's still there. I can keep moving it up until it can no longer touch anything. So then if I move it up far enough, I no longer touch the graph. So the last y value that was touched was at positive 9. So I can start my y values at 3, and it goes up until 9. Now, it's all the y values that are larger than 3. So I can see the 4 is touched, the 5 is touched, the 6, the 7, the 8, and the 9. So it's everything that's bigger than 3 or equal to 3 because it does touch the 3. But it's going to be everything that's smaller than 9, so below the 9. It does include the 9, so it's going to be less than or equal to 9. This is from a graph. Now, the domain was represented by time, and the range was represented by height. Because again, the domain is the x values and the range is the y values. So if we do the same thing with the context, we have a relation y equals 45x represents the amount of miles a train has traveled after x hours. The train can travel no more than 10 hours. So we do have a continuous data because it doesn't have to just travel for 1 hour or 2 hours. It can travel for 1 hour and 15 minutes. It can travel for 3 hours and 6 minutes. All of those amounts of hours can be used. So the domain here is going to be the x. X is hours. So the domain is represented by hours. Therefore, the range will be the amount of miles a train has traveled. So the range will be the miles. So when we're reading this, we have to think about the domain, how many hours can be gone. We need to think about this in context. There are negative numbers and positive numbers. If we're talking about hours, it cannot be negative because we cannot go back in time. But will this train go on forever and ever and ever, or will it have to stop? Well, right here it says that the train can travel no more than 10 hours. That is affecting the domain. So no more than 10 hours, but we also can't be negative. So when we're talking about our domain, the minimum amount of hours the train can travel for is 0 hours. It doesn't have to leave. And then we have our x. And then we have the most amount of hours that the train can travel. That's why we know what it represents. The most amount of hours. It can travel no more than 10 hours, but it can travel 10. So that's as far as it can go. And when we write our set notation, our inequalities, is all the hours that are bigger than or equal to 0 hours, but it's also the numbers that are less than or equal to 10. So if we read this, x is greater than or equal to 0, and x is less than or equal to 10. Now for the range, which is the amount of hours. Well, the minimum amount of miles that the train can travel is 0 because it doesn't have to leave. So we know that the minimum will be 0. We know that y is our range. But what's the maximum amount of hours or maximum amount of miles that the train can travel? We know that if we input x's, we get an output of y's. Well, the most amount of x's we can input should give us our maximum output as well. So if I write out that y is equal to 45 times the maximum amount of hours the train can travel is 10, if I multiply that, 45 times 10 is 450. So the maximum amount of miles the train can travel is 450 miles. So it'll be y is greater than or equal to 0 because it's going to be the miles equal to 0 or more than 0, but it'll be less than or equal to 450 because we can go up to 450 miles and that's as far as we can go. But again, this is a continuous data set because the train can go 1 mile, 2 miles, 2.5 miles, 29 miles. Instead of just very, very specific amounts, it can go anywhere between 0 and 450. So this would be connected because it can include every x value between 0 and 10 and every y value between 0 and 450.